Today's video will introduce us to something known as homeostasis, specifically human homeostasis. What exactly is homeostasis? Well, homeostasis is a process that allows us to maintain our internal environment despite dealing with an external environment that is constantly changing. You see, the conditions with our body can fluctuate a whole lot for many different reasons. A hot day outside might cause an increase in our body temperature. The consumption of that delicious hamburger will increase our blood glucose levels. Or the stress from studying from that big test might raise your blood pressure just a little bit. Fortunately, our bodies have mechanisms to counteract these changes and bring us back to those normal conditions where our bodies function best. I'm talking about homeostasis. All homeostatic mechanisms will have three components involved in the regulation. The receptor will sense any fluctuation within the environment and proceed to send a signal to the control center. The control center will then determine what sort of response is required to the change, and it will send the signal to the effector. The effector will then receive the signal and adjust accordingly. When the effector adjusts in a way that attempts to stabilize a variable, that is, bring it back within a normal range, it's called a negative feedback loop. While positive feedback loops also exist within the human body, negative feedback loops are far more common and will therefore be our focus today. So let's look at one of our earlier examples of homeostasis, that is, body temperature. Temperature homeostasis, also known as thermoregulation, is happening constantly within our bodies. Let's see how our body adjusts on those hot, sunny days. A section of our brain, known as the hypothalamus, helps us detect fluctuations in temperature. It receives signal from receptors on the skin, as well as internal structures, and decides what should be done. This is just like a thermostat in your house, turning on and off the heating or air conditioning. The hypothalamus links the nervous system, where the receptors are, to the endocrine system, a collection of hormone-secreting glands. If the hypothalamus detects an increase in temperature, it would signal certain glands in the body to secrete sweat, which would in turn cause heat loss due to evaporation. On top of this, the hairs on your body will lay flat, releasing warm pockets of still air caught between them, and the muscle walls of the arterioles will relax, causing an increased flow of blood to the capillaries in the skin, allowing more heat to escape. In cold environments, we would see the opposite happen. The hypothalamus would signal the glands to decrease sweat production, the muscles will cause body hairs to stand on end, and blood flow will be directed away from the outer capillaries and towards the warmer core of the body. We only looked at one example of how stable levels of a variable, in our case temperature, is maintained in our body. But as you can see, homeostasis occurs with many other variables, ensuring that our bodies function at their optimal condition. I hope you learned a lot from this video and will continue to learn all about homeostasis. Thanks for watching.
Created using Powtoon.
Through homeostasis, we are able to maintain a number of internal conditions in balance. Much of this maintenance is achieved through negative feedback mechanisms. So take temperature, for example. Our body's temperature must be balanced and kept relatively constant. If there is a stimulus which disturbs this balance, perhaps causing a high body temperature, then our negative feedback mechanisms will then eliminate the stimulus and return body's temperature to normal. If a stimulus causes the body's temperature to drop below normal, then negative feedback mechanisms will then return the body's temperature to normal. And so thus negative feedback mechanisms make the original stimulus go away. The same principle would apply to other aspects of our physiology as well. So if our blood pressure were to be too high, or our blood calcium too high, or our blood's pH to be too high, then negative feedback mechanisms would eliminate this stimulus and return these conditions to normal. And the same would apply if our blood pressure were too low, or our blood calcium levels too low, or our blood pH too low. Negative feedback mechanisms would then return these conditions to normal. So negative feedback mechanisms will respond to a stimulus which disturbs homeostasis by making the stimulus go away, by returning the body to its normal state. There are also examples of positive feedback mechanisms where the body's response will make an original stimulus more significant. So for example, during an action potential of a nerve cell, a little sodium enters the cell, and the body's response is to allow more sodium to enter the cell, so the response exaggerates the original stimulus. During labor, stretch on the uterine wall causes the release of oxytocin, which causes uterine muscle contractions, which then causes even more stretch on the uterine wall. Very often, positive feedback mechanisms are involved in disease. So, for example, during heart disease, damage to a blood vessel lining can cause the buildup of a plaque, which increases blood pressure, which causes even more damage to the blood vessel lining. Or decreased respiration can deprive brain centers of oxygen, including those which control respiration. And as nerve cells die, then respiration levels can drop even more and oxygen levels can drop even more. So positive feedback mechanisms are often involved in disease.